Congratulations, you're moving to the next level. Your next opponent is you.
Can a wireless network become so fast that downloading several 4K movies takes less than a second? More than 2 billion people already use 5G, yet researchers believe the world could soon need a network that is up to 100 times faster for the next generation of technology. China is investing billions into 6G research, and if that effort succeeds, it could reshape everything from AI and self-driving cars to the global technology race. When 5G arrived, it felt like the future had finally arrived. A 2 GB movie that once took several minutes on 4G could now be downloaded in under 20 seconds under ideal conditions. Compared to 4G speeds of around 20 to 100 megabits per second, 5G can deliver several gigabits per second. Yet the biggest challenge is no longer speed. By 2030, experts expect tens of billions of connected devices to be online, including robots, drones, smart factories, autonomous cars, cameras, and medical equipment. Networks designed mainly for smartphones could soon struggle to handle that enormous amount of traffic. While many countries are still expanding 5G, China has already shifted its attention towards 6G. The government created the IMT 2030 6G Promotion Group, bringing together universities, telecom companies, and research institutes to develop future wireless technology years before commercial rollout. China has also approved dedicated trial spectrum for 6G testing, giving researchers a head start. Winning the race is about much more than internet speed, because the country that helps define global wireless standards can influence future chips, hardware, patents, and communication systems used around the world. What makes 6G different? Most people think 6G is simply a faster version of 5G, but the vision is far more ambitious. Researchers are designing a network where communication, artificial intelligence, satellites, sensing, and cloud computing work together as one intelligent system. Instead of only transmitting data, future networks could also detect their surroundings, locate objects with extreme precision, and help connected machines make decisions in real time. Industry experts even believe AI will become a built-in part of the network itself, automatically managing traffic and optimizing billions of connected devices every second. One of the biggest technologies behind this vision is the terahertz spectrum. Today's 5G mostly operates below 100 gigahertz, while many 6G researchers are exploring frequencies between 100 gigahertz and 1 terahertz, where enormous amounts of data can be transmitted simultaneously. To put that into perspective, a laboratory speed of 1 terabit per second equals 1,000 gigabits, or about 125 gigabytes every second, fast enough to theoretically transfer nearly 50 HD movies, or around 5 4K movies, in just 1 second under ideal conditions. The trade-off is equally fascinating. Terahertz waves are so tiny that they measure only a fraction of a millimeter in wavelength, allowing them to carry massive amounts of information. But they are also easily weakened by walls, rain, and even moisture in the air. Solving that challenge is one of the biggest scientific hurdles standing between today's 5G networks and tomorrow's 6G future. Early laboratory demonstrations have shown wireless speeds approaching 1 terabit per second under controlled conditions. That equals 1,000 gigabits, 1 million megabits, or roughly 125 gigabytes every second. Since a modern 4K movie is usually around 20 to 25 gigabytes, several movies could theoretically be transferred in less than 1 second during experimental tests. Those speeds are still limited to research environments, but they show how much room wireless technology still has to grow. If terahertz frequencies are so powerful, why isn't everyone using them already? The answer is simple: physics. These extremely high-frequency signals lose strength quickly, struggle to pass through walls, and can even be weakened by humidity and rain. Engineers are developing advanced antennas and signal processing techniques to overcome these problems. But building a reliable terahertz network remains one of the biggest engineering challenges in telecommunications today. China is not alone in this race. Companies like Nokia, Ericsson, Samsung, along with research groups in the United States, Europe, Japan, and South Korea, are investing billions into 6G development. China's biggest advantage is its enormous telecommunications infrastructure. With hundreds of thousands of 5G base stations, large manufacturing zones, and extensive research programs, the country can test new technologies on a much larger scale than many competitors. Whoever develops the best equipment first could shape the global supply chain for years. The biggest impact of 6G may not be faster phone downloads. It could completely transform manufacturing. Modern factories already use thousands of robots, sensors, cameras, and automated vehicles that exchange information every second. Future 6G systems aim to reduce latency to fractions of a millisecond, allowing machines to react almost instantly. A factory with 10,000 connected devices could coordinate production more efficiently, detect defects faster, and reduce costly delays, making wireless communication as important as electricity on the factory floor. Autonomous vehicles are another major research is accelerating. A human driver typically needs about 1 second to react to danger. At 100 kilometers per hour, a car travels nearly 28 meters during that single second. Future low-latency networks could allow vehicles to exchange safety information almost instantly, helping nearby cars react much faster. Traffic lights, emergency vehicles, road sensors, and connected cars could all communicate together, creating transportation systems that are smarter and safer than today's networks can support. China's rapid progress in 6G research has caught the attention of technology leaders around the world. Jensen Huang, CEO of NVIDIA, has repeatedly said that future AI will require communication networks far beyond today's capabilities because billions of intelligent devices will need to exchange data almost instantly. While he hasn't endorsed any single country's 6G program, his comments highlight why nations like China are investing so aggressively. Meanwhile, Ren Zhengfei, the founder of Huawei, has said that 6G research is a long-term investment and believes the technology will eventually transform industries far beyond smartphones. Huawei has continued investing heavily in 6G despite global restrictions, showing how seriously China views the next generation of wireless communication. The interest extends far beyond China. Pekka Lundmark, CEO of Nokia, has predicted that 6G could become commercially available around 2030, enabling technologies such as digital twins, immersive communication, and advanced industrial automation. Researchers at organizations like Ericsson, Samsung, and leading universities have also emphasized that 6G will not simply deliver faster internet, but create intelligent networks where AI, sensing, satellites, and cloud computing work together seamlessly. That growing global consensus shows one important reality. Whether China ultimately leads the race or not, its rapid investment in 6G has pushed every major technology company and government to accelerate their own plans, turning 6G into one of the biggest technological competitions of the decade. Despite the excitement, several major obstacles remain. Terahertz signals still have limited range, making them less suitable for wide area coverage. Heavy rain and moisture can reduce performance, while processing enormous amounts of data requires more energy-efficient hardware. Building millions of new small cell stations would also cost billions of dollars. On top of that, international organizations still need to agree on common 6G standards, meaning widespread commercial deployment is unlikely before the 2030s. Every generation of wireless technology has changed the world, and 6G could power the next era of AI, robotics, autonomous vehicles, and smart industries. Although commercial 6G is still years away, the global race has already begun. If China leads the 6G era, it could shape the future of technology, manufacturing, and global communications. One question remains: when 6G finally arrives, will it simply make the internet faster, or will it completely change how the world works? If you enjoyed this video, don't forget to like, share, and subscribe for more content.